Welcome to the tutorial for Mosquito's plugin suite for Grasshopper and Rhino. We're going to be looking at Twitter, the Twitter component, and Google component. The Twitter component allows us to go into Twitter's social media network and look at what people are saying, extract those conversations, and start to plot them around on our canvas or in our Rhino viewport. The Google component lets us plot directions. Specifically plot directions from one location to another location. So this could be plotting the path from one user to another user. So to start, what we need to do is we need to open up Grasshopper, and before you start this tutorial, you should have downloaded the Mosquito plugin suite and installed it inside of Grasshopper. You can find it on studionew.net or grasshopper3d.com, or you can find it on Food for Rhino. But the latest plugin suite will be here on my website. So once you've installed the plugin suite, you should be presented with a new submenu called Sonic, and over here you'll have a whole variety of plugins to choose from. Now the ones we're going to be looking at are Sonic Tweet, and we're going to be looking at Google Direct, we'll be looking at Sonic Location, and we'll be looking at Sonic Tweet in this tutorial. So to start, create a Sonic Tweet component. And what this does, it allows us to go and look for a conversation taking place and receive all the messages that contain a particular string or piece of text that we're searching for. So here I'm going to type in taxi, and I'm going to see what that returns. So here you can see it returns 10 different messages. Now, these messages basically are the messages in Twitter that contain the word taxi, but you'll notice we only have 10. To increase our search, we can increase the number of results to the maximum being 100. So once we've got 100 results, you can see that we now have far more returned messages. And what we can do is we can start to pick out only those that have geolocation. Now, not all messages have geolocation. Users can opt out of having given over their geolocation every time they tweet, or they can leave it on. If they leave it on, we can find out where they are. So here we can use a cull pattern, and I've included this has geo component to allow us to pull out only those messages that are geolocated. So what this means is that it will give us a message, and it will give us usernames, and it will give us a date, it will give us a location. And most of the time the locations will look like this. But we're not interested in just names. If you want, you can reverse geocode these and also display them. But what I'm really interested in is a finer grain of detail, and that's latitude, longitude details, or locations. So you'll notice that even though we have this detail, we don't see the points in our Rhino viewport, and I'll get to that just now. In addition to these other outputs, we have the user profile picture URL, where you can download a user's picture. We get the number of followers they have, and the ID. The ID is a unique ID for every message on Twitter, meaning you will never duplicate your messages if you match them by ID. So what we're going to do now is make sure we can show this in our Rhino viewport. Now, keep in mind that latitude and longitude deals with very tiny numbers. So on our Rhino viewport, we're going to actually have to zoom in to see these. But we first need to draw them. So the first step is to reverse these coordinates. The reason being is that when these coordinates come out of Twitter, they're reversed. And I'll show you what I mean by that. So if we create a point from these, we get 2 points down here. And if this is the center of our planet, if that's the horizontal line in our planet, this is in the southern hemisphere. Now, I know from experience that this is not correct. And so what I want to do is flip the x and the y, or the latitude and longitude. So here I'm going to use a deconstruct component, and then I'm going to use a construct component. And what that allows us to do is swap the x and the y. And there you can see our points are being drawn in the correct space. So we can go ahead and hide these. And there are our 2 conversations taking place. Now, what if I wanted to narrow this down? So to narrow this down even further, what I could do is specify a location around which we want to search for tweets. So in order to do that, we need to put in the latitude and longitude for our Twitter search. And what I'm going to do is I'm going to pull out a location by using this component that I've provided called sonic location. And what sonic location does is it takes a piece of text, and we can write anything in here. And I'm going to use New York as an example, near Columbia University. So 116th Street and Broadway. And now if I plug this in, this will query Google's API and return a address and a point for that specific location. So here is the address. Keep in mind this is all I put in. And it will return a point for that address. Okay, so now that we have that point, we can use that to search around that area. Now, one thing to keep in mind, just as we did over here, we also have to swap the x and y when we feed Twitter information based on latitude and longitude. And in order to pull out these individual numbers, we use a deconstruct component, and we feed in our latitude and our longitude. So you can try this out for yourself, but the idea is that these essentially have to be reversed. So now you can see that not much is actually being detected. We are getting messages, right? And the locations seem correct. It says West Side Highway, New York, London, but it's still far too broad. And you can see that none of the messages are actually geolocated. Now, if we change the text and we change it to something like the, which is very generic, we still don't get anything. Let's try something else like okay, so now we get several geolocated points, and they all say happy, or have happy somewhere in them. Now, if we look at the locations, the raw locations, we'll find that they're pretty far spread out. It's zoning in on New York, which is over here, but it's not confining it to New York in terms of the radius in which it's searching, if that makes sense. You can see we're getting things like Colorado, Palm Springs, University of Delaware. So the reason it does that is because we haven't set the georadius. And the georadius allows us to set the bounds, or the circle in which the spatial boundaries in which Twitter actually searches for conversations. So I'm going to put 5 in there, and that will basically result in 5 kilometers. And here we get a whole bunch of conversations now taking place that contain happy, And if we wanted to double check to make sure these are correct, and we hover over location, that looks somewhat correct. Upper East Side, Astoria in Queens, that looks fairly correct. So what I'm going to do now is I'm going to take this as an example, and I'm going to plot the movement from one user to another. But before I do that, you can see that because things are parametric, we can go and change the conversation now. So I'm going to say Columbia, see who's talking about Columbia University, and there we have a bunch of points. And you can see the concentration is probably coming from Columbia's campus. Now, what we can do is we can see how long it takes to go for one user to potentially walk to another user. And to do this, I'm going to use the first two people over here in this list. And you can see we have, if I move this down, we have numerous users talking about something that contains Columbia. And here we can see the conversations taking place. So what I'm going to do is I'm going to find out what the actual address is of the geo coordinates that they're tweeting from. And we can use the sonic location component to do that. And if you plug these two in, what you should get back is a number of points that describe where those people are tweeting from. But one of the problems with this is that the address says there's more than one address. So the address says 535 West, 116th. But then for the same tweet, it also has all these others, and that's because the API doesn't return just a single address. It will return things in sequence. So the most refined address being the street address, all the way up to country or continent. So what we're going to do is we're going to just pull out the first item. So I'm going to use list item, and I'm going to put in the 0 index, and that will just pull out the street address. It will leave all the other addresses out of the equation, and I'm going to flatten this. So here we have all the locations associated with tweets. So once you have that, what we can go ahead and do is we can take out the first two conversation locations and see how long or how far it's going to take to walk from one user to another user. So to do that, or let's try something else. Let's go from the 0 user to the 9th user. So I'm going to use list item, and I want to see how long it takes to go from the first user to the the 9th user. And what that will return are those individual addresses. So now that we've done that, we can use the Google Direct plugin, and that's located over here. Looks like a little planet. And we can plug in the from and the to, and that should plot a path from one user to another. Now, in order to show this work in a more meaningful way, I'm going to increase the search radius for Twitter to 25. Sorry, I increased it to 10. So as you can see here, it's getting a bit better, but let me increase it to a larger distance. The idea being I want to show you how this plugin can show you the path between two users over a larger area. Okay, so we'll do 3, 4. Okay, so we get something like this. So here I'm going between the 0 user and the 4th user. And what we can do is we can see who those are by plugging this into the username. And what we get is the username associated with that conversation, and a username associated with this conversation. Or this piece of text. So the next step is we can actually plot this line out, this walking path, and we can use polyline, not walking path, driving path. That's a very important distinction. And then what we can do is we can see what the potential route might have been. We can get back how long or what distance it takes to walk from the one user to the other, drive, the duration of the driving. And this might be fine, but what if we want a higher resolution? Well, we can choose to look at the walking aspects. And we can plug in walking into mode. And here you can see the time increases, but the distance pretty much stays the same. So now that we've done that, we can start to look at the various walking distances and paths between various users. And the next thing we can do is we can go and increase our search radius to maybe 100. And again, okay. So the next thing I'm going to do is go back here and change the conversation. So I'm going to change it to the, or how about hey. And you can see that it now plots out a far more detailed path, because what it's doing is it's looking at the walking distance between people that are hundreds of kilometers away. Here, there's one person in New Jersey and another person in New Jersey essentially talking to each other. So what we can do is we can narrow the search down again. And here we're looking at people talking about things. And the one person's in New Rochelle, New York, the other one's in New Jersey. So let's really narrow it back down to 5. And again, looking at, okay, so what I've done here is I've just refined it a bit more, the whole definition. And what we're looking at is a search radius around 1/16th and Broadway near Columbia University. And the search radius is 2 kilometers. And we're looking for 100 results. And from those results, we're getting roughly 29 geolocated tweets, and from those we can pull out the users' IDs and their tweeting locations, and then look at the walking distance and path between those two users. And again, we can change this to driving if we wish. And it will show the driving path. You can also change it to cycling. and that'll show the cycling path, which is pretty much the same as the driving path. Depends on the mapping API. So the next thing I'd like to do is extract more information about the individual users. And so to do this, we can go and pull out a user name and the information associated with that username. So to do this, I'm going to use Sonic Tweet User. Now, when we use this plugin, what it does is it takes the user, and if you look at the output, it gives you their name. Sorry, not their name, their ID. It gives you their name. It gives you their location. It gives you info about them. It tells you when they were essentially created their account. It tells you what time zone they're in, tells you what language, tells them their most recent message or status message. And so it can also give you a lot more than that if you look into their follower IDs, if you want to get their followers. So I can use a Boolean and toggle this to true. And what it should do is it should give you back their follower IDs. It doesn't 5,000 at a time. You can't really do more than that, but it'll give you 5,000 of their followers in return. And then it'll give you their profile pic, so you can go see what they look like if you wanted to. So the next step is, now that we have that, and this is information that you can use in a numerous number of ways to do research regarding social media and people's movement patterns and tracking them over a long period of time, etc., etc. But one thing that comes up time and again is, how do we plot this path or these points and these tweets across a map, an accurate map of New York. And I'll get to that now, but before I do that, I just want to point out that we can go ahead and get all the names of our users, the real names. So if I plug in this list of user IDs, or user handles into user, what I should get is a panel that, or text in this panel that represents their actual full names or something close to it. Now, once I have that, I'd like to plot those out to points in our viewport. So I'm going to use text 3D, text tag 3D, and I'm going to use this text and plot it out onto these points. And you'll notice that this is really big and green and blocks a lot of graphic data out, and that's because we haven't set the size. So I'm going to set 0.01 and plug it into S. Great, so now we can see who's talking about what where. Now, moving on, what I'd like to do is I would like to be able to plot this, like I said, on a real map of New York. And what I've gone ahead and done is I've exported some information from from a shapefile with building outlines that I got from an online database source called nyc.gov, and here they have a shapefile of Manhattan. And from that shapefile, I exported some information So the information, the shapefiles come in something like this, and I open this shapefile in ArcGIS and exported a portion of that. And that portion I'm going to import. So these files are included in the download, so you can download the working files from this tutorial and use them. Okay, so the shapefile is very helpful in that it provides us with all this geographic information, vector information with buildings and outlines of streets and things like that. But you'll note that down here in the left-hand corner, look at the scale. It's far off from what we've been dealing with. If we zoom out, you can see that our points are all the way over here on the left-hand side of our screen. So if I zoom in, here's our points. Now, the problem with this is that when you deal with latitude and longitude points over here, they're not going to be the same as when you import a map from ArcGIS, because those are projected state plane vectors. And they're usually in feet or meters. It depends on the state plane that you're working with in ArcGIS. And you can see they're far, far from each other, which means they're not going to overlap. So the first step is that we need to make sure we have one file, an important file with us, to enable us to project our tweet locations onto this map. And that file can be located with your shapefiles if you're in ArcGIS. And it should end with PRG, which stands for projection file. And so what I've done is I've taken that file, I've saved that file, and you can usually take it straight from the ArcGIS folder containing the shapefile. And I'm going to open this in a text editor, and you'll see what it looks like. It's a piece of code, and this piece of code will tell a component that I've written how to reproject coordinates from latitude and longitude to a state plane. So we don't need to touch this code or do anything with it, but you do need that file. And this is the way it works. So what we're going to do is I'm going to pull everything out over here, and I'm going to work with these points. And I'm going to use this component called GeoProject, and I'm going to plug the points into points. And I need to provide a WKT file, which stands for well-known text transformation. That is essentially the text that was in the PRJ file. Now you can copy and paste that text, or you can just point to the file itself. So here I'm going to make a read file component, and I'm just going to point to that file. So I'm going to say set one file path, and I'm going to point to the PRJ file, or go to the original Manhattan Pluto download and point to nmmap pluto.prg. And so you can see as soon as I do that, there are our tweets located, our social media messages located across that area of Manhattan. So now that we have these points, what we can do is we can use them to also plot our text. And I'm going to increase the text size because it was just way too small. So there you go. There are the names of people tweeting in different locations. So now that we have these names plotted out, what I'm going to do is I also want to convert or reproject the directions or the directional path from our Google Direct plugin. And so in order to do that, what I'm going to do is I'm going to go over here and copy this GeoProject plugin, and I'm going to feed in the points from our Google Direct plugin. And now I can draw a polyline from those points, and I can offset those points, or that path, sorry, and then loft it to give us a thicker line. Now this is just a quick hack, just to make things more visible, and it should look something like this when it's finished. And don't forget to flatten your lofting inputs. So this should give you guys enough to go on in terms of how to track people, how to extrude paths. You can see everything's really parametric. So what we can do is we can go back and we can change the mode to, say, driving. And you can see how that changes. And it's very accurate. You can see it's going down the street lines, taking that curve, that bend. And yeah, when you want to see the spatial disparity between different users, this is a very good good tool to be able to have to track movement from one location to another. We can also go back and we can compare different users. So here this is comparing Drew Ramsey to Negrosimo, and here we can go and we can see how long it takes to go from Drew Ramsey to Lester Baptista. And if we wanted to, we can change the whole thing altogether by going and changing the conversation topic. So we could change it back to Colombia and see what that brings up. And here you have mostly the tweets taking place on Colombia's campus. So this is Broadway, this is Amsterdam, this is Colombia's campus. Let me just pull the size of the text down. And so here you can see the conversations taking place on campus to do with Colombia in the topic. And what we can do is we can once again go and change the relationship between different users. Change the relationship between different messages from different users in terms of locating the directional path from the Google Map API. All right. So again, just to wrap it up, here this plugin called Sonic Location enables you to plug in any given name that you would that you have for a street in a city or an intersection, and what it will do is it will return a street address and a latitude and longitude for you, as well as return the type, in this case an intersection. The next plugin that we used, Twitter plugin, will allow you to search for messages containing a piece of text or a phrase, and you can set the latitude and longitude around which to actually search for those messages, and that's why we needed this point. The search radius was set to 2 kilometers, and the number of results we wanted were 100. But keep in mind that not all locations have geo-coordinates, and that's why we use this cull pattern from hasgeo to pull out only the things here that have geolocation, meaning latitude and longitude associated with them. Further down the way, we used the Sonic Tweet user component, and what that did was it converted the user handle to full names, provided the user allows for this, but most users don't know to turn this off, so you should have access to those. We then used the Google direction component, which allows us to see the movement path from one user to another user based on where they're tweeting from. And remember, in this case, they weren't talking to each other, they were just talking about the same thing. And this, again, the locations of those particular tweets were pulled out by using the sonic location component. Now, at the end of the day, when all is said and done, we want to be able to project this onto a map, an accurate map from ArcGIS or some other GIS software. And in order to do that, we needed to reproject that information, all those points. And for this, we used GeoProject. And we were able to do that by utilizing the projection file that comes up with most shapefiles for ArcGIS. And it ends with .prg, pointed to that file, plugged it into WKT, because WKT stands for well-known text transformation, which is what is embedded in that file. And that allows us to basically reproject those points onto a state plane, in this case being New York. At the end of the day, we have a fully parametric system in which we can go ahead and change the topic of conversation, we can change the search area, and everything should update automatically. So here I change the topic again, and we can go ahead and start looking at the different directions from one user to another user. So I'll leave this with you guys, and at this point you should now be able to see that there's a big difference between walking and driving. Here we needed to get across Central Park because what I'm looking at is a conversation that was posted by J.S. Kluter to Drew Vialonis, and here I'm switching between cycling, driving, and walking, and you can see walking takes a totally different path across Central Park. And now we can easily look at that, go up here and see that it takes 2.4 miles, 47 minutes, and driving will take roughly 8 minutes. So that's an overview of the Twitter component suite, along with the Google API suite, all available in the Mosquito plugins that I've programmed and have made available for download on Grasshopper 3D, Food for Rhino, and StudioNew.net.